Hello friends, we are back with a new video around obviously with a new fungus regarding fruits, and this is an Indian fruit or rather local Bengali fruit. It is known as Jujube. It is, or you can say it's a Chinese date or Indian date. You can say it is Indian date. You can say in Bengali we say cool. So this is a very sour fruit, mainly used for making sour sauces. But this has acquired a fungus. So when kept long time, it acquires a fungus. So this is maybe this is a black mold. We are going to investigate this fungus um, under a laparoscope, and we will be resecting this fungus and we will be putting it into the culture media. So that therefore we are going to the lab and we'll be doing this resection. Regarding this fungus, we will be talking because this fungus is a very fringy and spongy fungus. You will see later on. So we will going to look at this fungus. So this is a very this is going to be a very interesting video perhaps for you, and we will be seeing the whole resecting process and the fungus extraction and going to put the fungus into the culture media, and we will be going to the lab and do it for you. So please be with me and see the video. The laparoscopic view of the fungus. As you can see, we are recording through a laparoscope, and you can see the fungus. So that is a very beautiful grey mold fungus from the fruit, jujube fruit, the Indian date, as you can see. So this is the fruit and the fungus protruding out with black heads. So the stem is white and the head is black, so it is almost a black, almost looking like a black fungus. It may be a black fungus that we will see under morphology, under microscope. It is looking like black fungus. Now it is known as grey mold. So we are now going to excavate this fungus. It is protruding from inside. It's coming from the inside of the fruit. Now it has protruded out from the surface. Now we can see this is the fungus. So we are going to excavate the fungus. So we are going to excavate. So excavation will start. We are getting ready. You can see the fungus. This is the stem of the fungus, and we have started the excavation with the help of a forceps. We are going to excavate the fungus, and you can see the laparoscopic view. So this is the fungus. And we have started excavation with the forceps. As you can see, we are removing part by part. We are removing the fungus. So that is the fungus in the forceps. You can see that is the mold. We have just excavated, resected the fungus. We have actually resecting the fungus from the surface of the rather the Indian date. You can say Jujube. It is a Latin name as Jujube. So this is the other side of the posterior side of the Jujube. So we are going to excavate the fungus. The fungus has gone from the anterior side and also as well as in the posterior side of the Jujube. So we are extracting the fungus. So this is the anterior side. We are just excavating. We are catching the fungus and we are just excavating. So you can see the surface of the fruit now. It is a red color, reddish brown color fruit, and the fungus has been excavated, resected. The fungus has been resected. And there is no fungus. The fungus has now been resected and is getting put in the culture flask. So So turning the other side, the posterior side with the forceps, so that we can see the other side of the fungus. So that is the opening from where the fungus has come out. So we are turning the fruit, and you can see the other sides, all the sides. You can see this is the fungus protruding. The fungus was coming out from that protruding end. We can see the fungus. This is the fruit we have catched under by the forceps. We are holding the by the forceps. So that is the fungus end. So now we are going to cut open the jujube fruit with a scalpel. We are going to cut open it, and we will see inside what is there, what is the condition of the fruit. That will be more interesting to go inside the fruit, and that we will see in the laparoscope very soon. Just that is the protruding end. So we will just cut open the fungus, and you can see the fungus has been cut open, and inside the view you can see we are inside the fruit, and that is the green mold, that is the grey mold, that is the source of the grey mold. So these are the sides of the fungus, the fruit, and that is the green mold, grey mold. The seed has gone completely rotten, and the grey mold has gone. That is the scalpel, that is our forceps, and the forceps has been introduced, and we are resecting the grey mold, the source of the grey mold, or the root of the grey mold, by the help of this forceps. We just protruding the grey mold, we are stabilizing, and we are just resecting out the grey mold. So this is a very slow process. As you can see, we have resected out the grey mold. Is there the condition inside the fruit? You can see, and all has got rotten, and we are resecting. Again we are resecting. We are just resecting with the help of a scalpel. That is the scalpel. We are resecting. We are resecting the fungus, and that is the scalpel. So we are resecting the fungus, and we just then we will be taking the sources with the help of a forceps. We are going to take the sources, and we will be putting in the culture media. So that process is going on. We are cutting and resecting. We are cutting and resecting. This process is a very slow process. We have to slowly do it with the help of under the vision of a laparoscope. We are slowly doing it. The resection is done. Hello friends, so we are now back after 5 days. So with this is the jujube fungus, and that Indian blackberry, Indian berry, or Indian date. Now you can see the ramback agar has changed the color due to the fungus development. As you can imagine, just imagine that it is a fungus has developed, and now it has become yellow in color. So this is we are going to check under the same 400 microscope for first time investigation of this fungus. So what fungus it is, and let us see. It may be black mold, it may be grey mold, it may be sticky water atra, it may be anything. It can be citrus vibrata also, or anything else. That can be Clostridium that fungus with 18 mycotoxins. So that can be there. Clostridium can be there. So we will have to examine what is it. But Clostridium may not be, because Simona cluster was a cluster fungus. So this is not a cluster fungus or cluster fungus. This is a fringe fungus. So it not be Clostridium. It may be something like that. Molds, some molds it may be, fringy molds. Now we are going to call this as Jujube fungus, because it was obtained from Jujube. So we are going to call it as Jujube fungus. So let us see what is this Jujube fungus. It looks like under TCM 400 microscope. So here is a petri dish. We are just going to take around 3.5 ml, just 3 ml like that, 3.5 ml, and we are just going to put this to the petri dish and just examine the fungus. So this is our, it has become very sticky now. It's a very big thing is coming to the pit. So this is lots of debris are there. As you can see, some macroscopic debris are also visible. So let us see what this jujube fungus actually gives us. So you can see a new fungus, and this is cystic bloata. This is a bloata fungus or bloata fungus, or you can say it's a cellular fungus also. You have seen the cells in the beginning. So this is cystic bloata. This is a very dangerous fungus and very similar to black fungus or aspergillus. So these are the other colonies. The microscope is getting focused. These are the bloata cells, just developing bloata cells. We are going to the other parts of the specimen. These are the bloata cells in front of you. The microscope here needs to be focused because this is floating in the culture media, so it needs to be focused properly. Otherwise, we want to see the cultures, see the specific geometry. So the microscope is getting focused. We have to see the focus it very carefully. So no, it is out of focus now. Again out of focus. So we are focusing again, and it is almost focused, and you can see the cysts, the bloata cysts, in the formation of looking like a mucor, and it is very similar to black fungus. So this is a mucor. So this is in front of you is a mucor, almost a mucor. This is cystic bloata. Just focusing. It should focused, and it is focusing. The microscope is focusing. So it is focused now. So the microscope is focused now, and you can see the bloata's head and the bloata stem and the neck of this fungus. So this is the cystic bloata, the developed cystic bloata. This is very similar to black fungus. Very similar to black fungus. This is one of the categories of mucors. This is very similar to black fungus. So you see other the mucors, other the cystic bloatas. This is a very dangerous fungus found in the Jujube. This is not a Jujube fungus. This is cystic bloata. We can call it as a Jujube fungus also. You can give a name as a Jujube fungus. It is found in Jujube. So you can say it is a Jujube fungus. These are the other sides of the specimen. Not very much scenes to see because this is a very new. It is a very preliminary stage of development. So other sides, so another Jujube is floating. Mucors are floating. Mucorites are floating. This is a mucorite fungus. This is a bloata, which is a mucorite fungus. The other bloata colonies are there, and it is focused, and you can see the mucorite cells developing. So this is a mucorite. You can see the mucorite colonies. So this will ultimately develop to cystic bloata. So this is the main cluster of the cystic bloata. Now the cystic cysts are clustered. From there they will separate into mucors and mucorites, and they will form the cystic bloatas. So when their stems will protrude, and they will form into cystic bloatas. So this is almost all about this fungus and the preliminary investigation. We are ending up almost. So nothing more to see. This is the preliminary examination. More and more bloatas, some information of bloatas are there. So almost this is end, and here we are ending up. So as you can see, the our second microscopic investigation of the cystic bloata, the bloata cells are prominent now. We can see the prominent bloata cells. They are very small, but they are prominent. So these are the bloata cells, and you can see the bloata colonies, bloata patches also, the cell colony patches, and therefore this is quite a good investigation as we have seen. This is a very big large bloata colony. This is a large bloata colony, as you can see. This is a large bloata colony. The bloata stretches are there. The colonal stels are there. These are the colonal stels. So these are the large bloata colonies, and bloata patches are there. So the light is increased a little bit, so you can see properly. The light is a little bit increased. It was too much dark, so the light has been increased, and you can see the bloata colonies. So these are the other parts of the slide. The light is a little bit decreased. This is the bloata colony, another bloata patch. That is the continuation of the previous patch. This is the continuation of the previous patch. So this is the bloata colony. These are the bloata colonies, as you can see. So these are the more and more patches, or the bloata bloata colonies, and the bloata cells are developed. The oocytes are there, bloata oocytes, cell oocytes are there. The baby cells, actually the oocytes are known as the baby cells, so they are also present, they are also visible. So this is the condition of the fungus now. It is in a very advanced stage. So these are the other parts of the slides. These are also bloata, small bloata colonies. You can say bloata or bloata, one and the same thing. So the microscope is getting focused, and you can see the bloata formation. Actually, this is a little bit hazy because the culture media has become very thick in small micropores of the bloata or the bloata. So the image is a little bit blurred here. This is because the culture media, it has become thick in these 15 days, so it is blurred, and the microscope is very difficult to focus. Now this is the bloata cells, the conjugated bloata cells. You can see here. Now it is a little bit clear here. In this mention, you can clear the two bloata groups, and connected with each other. This is a very big bloata group, and you can see this is the bloata group. Actually, this is the conjugation of the bloata. So this is the cystic bloata, the bloata cysts. Actually, these are the cysts. It is like a grape, bunch of grape. So these are the other cells. You can see again the fungal colony. These are the very much profused colony. So this is another profused colony here, floating, and the stigments are there, cells are there. So these are the condition of the bloata cells are there. You can see this is a very deep formation of the bloata cells. So it's an overgrown colony. So that is why nothing is visible in the TCM400 microscope. So it needs fluorescence. So the next part of the video we will see the fluorescence. So these are the portions of the bloata. So this is a stealth. These are the bloata cells, stealths. So these are the visible bloata colonies. I can see the culture media, the thickness of the culture media. It is very thick. So it is not allowing the microscope to penetrate through it, the other side of the layer. So we are seeing from the below of the petri dish. So this is the bloata and the phase contrast. You can see this is the phase contrast image. These are the bloata cells, small bloata, single bloata cells. Two cells are there. The two single bloata cells. So the microscope is, the culture media is not allowing to penetrate through. So it is so thick. So this is the bloata colony. These are the bloata stalagmites actually. The patches, so the bloata patches. You can see bloata patch. So this is a very beautiful fungus, and the mycotoxins will reveal how much dangerous it is. So that we will be waiting for. Now the slide is, the specimen is finishing up. We are finishing up the interpretation. So you can see the micropores, even the micropores are visible in the background. So this we will see in the fluorescence image. So this is the cystic bloata, as you can see. So these are the bloata colonies. And these are the bloata patches. These are the bloata patches, bloata cells, and when the cells are there, the microscope is getting focused and you can see the cells. So this is it. This is cystic bloata. As you can see, this is a very big bloata cell, and it has been stained in IRCP RA stain. So you can see the yellow spots of the mycotoxin inside the cell, and they are getting released one by one. That also you can see from the video. So this is the cystic bloata. It is a fantastic video fluorescence image, and you can see inside the bloata cells. Inside the bloata cell, the configuration of the cell. So the micropores are here. So this is the cystic bloata. So you can see the floating mycotoxins, and they are getting released. This is the mycotoxins are getting moving. Mycotoxins are moving. Some has become oxidized. Some micropores has become oxidized in the right hand side corner, top right hand side corner. That is the red corners, red cells. Red has been colored in red. This is another cystic bloata. This is elongated bloata cell. This has released all the mycotoxins. So this has become elongated and constricted. So this is another bloata cell. This is a very bright illuminating light. So the microscope needs to be focused. So these are the micropores. These micropores are consisting of trichothescene mycotoxin and botrytis also. Some other mycotoxins are there. Zearalenone is also there. So total, how many mycotoxins that will be seen? This is a very beautiful elongated bloata cell. No mycotoxins inside. The mycotoxins has all been released. The cell is empty. These are the dead cells. These are more mycotoxins. These are the more mycotoxins. The bloata is a very big bloata cell consisting of mycotoxins. The round mycotoxins. These are dead bloata cells. This is blue in indigo caramine. These are bloata cells. So this is also a mature bloata cell. It's a very beautiful, beautiful concentration of the dye of the indigo caramine. This is actually blue in color. This does not consist any mycotoxins. So if it consisted, you could have seen a very beautiful blue image inside these cells, but they are dead. Some are having mycotoxins, but that we will see later on. So some cells are ruptured because they are dead, so they cannot withstand the dye, so they have got ruptured. and the cells, their shape has just deformed. So this is the condition of the slide. You can see the cells are getting ruptured. Cells has ruptured. So this is another part of the slide. You can see the empty cells, the dead cells, empty dead cells. We are looking for any live cell which is stained in indigo-caramine, and you can see the mycotoxin inside. So that we are watching. So these are the micropores. You can see green and yellow dots. So green is the botrytis and yellow is the trichothescene. So that is revealed. The yellow is the trichothescene and the green is the botrytis. And that is some more patulins. Patulins are there. Silalurin is there. So these are the other parts of the slide. It needs to be focused. Microscope needs to be focused. And nothing else such. So here are dead cells. So these are the dead cells, also almost they are dead cells. So nothing to watch here. Some mycotoxins, micropores are floating. These are the floating mycotoxins. Mycotoxins are floated and gathered here and there. So therefore you are seeing the twinkling lights. So twinkling illuminations. So this is the beauty of the fluorescence staining, and now going to the other parts to see if anything new is there. So these are dead cells. These are oxidized dead cells. Some mycotoxins are there, but they are very feeble. Some glow is coming out, but that is very feeble. You can see some glows are there, but these are very feeble. You can very focusing the microscope on them, and you can see they are very feeble. On center part, and they are very feeble. Mycotoxins are there, but very feeble. So this is the condition of the bloata cell. This is a very new natal bloata cell. This is just emerging. This is a very neonatal bloata cell, just a neonatal cell. This is just emerging. This is another bloata cell, consists of a mycotoxin. These are oxidized dead cells. That is a patulin mycotoxin, patulin triangle. So these are the dead cells. So the slide is almost over. The visualizing of the slide is almost over. So this is cystic bloata under. So this is the mycotoxin. You can see the mycotoxin waveform, and in the 260 there is the trichothescene, the main mycotoxin, and the other parts are there, and then that is the many other mycotoxins are present. Total 10 mycotoxins are present. We can enlarge the spectrum, and you can see this is the lower half having the mycotoxins. This is having low absorbability, and the top portion, this is the lower portion, having the absorbance is lower concentration. Absorbance is low, so they are having a low concentration, and these are the higher concentration mycotoxins. So one of them is 260, that is the trichothescene, and this is in this place that is the other mycotoxins are there. So ustiloxin is there, silalurin is there. So total 10 mycotoxins are present. So this is a very dangerous fungus, as from the UV spectrum it has been seen.